You meet a woman named Linda. She's 31, outspoken, and highly intelligent. She studied philosophy in college. While she was there, she was deeply concerned with social justice and often participated in climate change protests. Now, which one of these is more likely? Number 1, Linda is a bank teller. Or number 2, Linda is a bank teller and active in the feminist movement. Chances are you picked the second option. Most people do. And like most people, you'd be wrong. You've just fallen for the conjunction fallacy. Hi there, I'm Matt, and this is Camping and Coding. Today, we're breaking down one of the sneakiest traps your brain sets for you, the conjunction fallacy. Please hit like and subscribe if you want more videos like this. Now let's jump in. So what is the conjunction fallacy? Well, it's a cognitive bias where we think that a specific, detailed scenario is more likely than a general one, even when it's not. In fact, this cannot be true. Why? Well, for that, we need to get precise for a second. In logic and probability theory, a conjunction is when two statements, let's call them A and B, must be true at the same time. The probability that just A is true is written PR of A, and the probability that just B is true is written PR of B. The probability that they're both true is written PR of A and, that's the logical and operator symbol, B. But here's the catch. The probability that both A and B are true is always less than or equal to the probability that just A is true, no matter how compelling the conjunction sounds. Now back to Linda. If we let A equal the statement that Linda is a bank teller, and B equal the statement that Linda is active in the feminist movement, then what we're really asking is the question, what is the relationship between the probability that Linda is a bank teller and Linda is active in the feminist movement, and the probability that Linda is just a bank teller? Well, we've seen this before, and we know that the conjunction can never be greater than one statement alone. Even if every bank teller is a feminist, the probability that Linda is both still can't be more than the probability she's just a bank teller. You can't add conditions and make something more likely. Let's draw this out. On the left, we have the circle of all bank tellers. We'll call that T. And on the right, we have a set of all feminists. We'll call that F. This middle section is the set that is the intersection of T and F. Now it's clear from this picture that the intersection can never be larger than either of the circles on its own. Yet the conjunction fallacy tricks us into thinking that it is. Here's a simpler example. You see an animal on the street. What's more probable? That it's some dog or that it's a brown dog? Easy, right? There are more dogs than there are brown dogs, so number 1 is more likely. But when we add a narrative to the story, like with Linda, the fallacy becomes harder to detect. Her story nudges us towards certain assumptions, even though the math doesn't change. The famous Linda example that we talked about comes from Daniel Kahneman and Amos Tversky, who were pioneers in behavioral economics. In the 1980s, they ran a series of experiments showing just how easy it is to fall for this and other biases, even for trained statisticians. Kahneman won the Nobel Prize for Economics in 2002 for the work that they did together, and Tversky would have shared the award had he not passed away in 1996 at the age of 59. Critics have argued that the wording in these problems sets people up to fail, and they have a point. When people are asked, out of 100 people, like Linda, how many are bank tellers, and how many are feminist bank tellers, they're far more likely to get it right. Thanks for watching. If you learned something, give this video a like and subscribe to the channel. See you next time.